Hello everyone. In this video we are going to solve an integral which is very easy and basic but a bit tricky. So maybe therefore it is asked frequently in the interviews, math interviews or other interviews. So we'll go over this. The integration is given over -1 to 1 and the function is 1 by x square. Okay, and it is said that it is equal to -2. Okay, so we'll check whether this is so. First, if we want to just do the integration, then it is what? -1 to 1 by x square dx, right? So if I remember, 1 by x square integration gives you -1 by x. Okay, and then you can put the lower and upper limit. So lower limit here is -1 and upper limit here is 1. So now if we carefully calculate this, this will give -1 by 1 minus -1 by -1. So -1 by 1 gives us -1, and secondly minus of, again this gives 1, so 1, and it indeed it gives -2, right? So that was the problem. Okay, so it is -2. So then is this correct? The question is this correct? Okay, so I will have, before we check correctness, I have two confusions. Okay, the first one is the following. Okay, the function here is fx equal to 1 by x square. Okay, and this function is always bigger than 0 on the interval -1 1, which is given and over which we have to integrate the function. Well, so then function, if it is always positive on some interval, then the integration of that same function must give you something bigger than 0, because it is always bigger than 0 on that interval. So if you integrate it, that must be bigger than 0. So function bigger than 0 means function is above the x-axis, right? The plot or the graph is above the x-axis, and therefore if you integrate, what you will actually get is the area under that curve over the x-axis, which is fine. But if the curve itself is lying above x-axis, then area under the curve is also positive. This is simply saying that 1 by x square integration 1 by x square dx must be positive when the function is positive, right? Well, if this must be positive, then -2 is a confusing value. This is negative value, right? This is the first confusion. Second confusion is this. So the function fx equal to 1 by x square, again fx equal to 1 by x square is an even function. If you remember what is even and what is odd for functions, so even function means f of -x must be equal to f of x. Okay, so f of -x is what? 1 by -x square. Okay, which is nothing but 1 by x square. On this side also fx equal to 1 by x square, which is given. So basically f of -x equal to fx, which means fx equal to 1 by x square is an even function. Okay, and then for even functions we know that -a to a, okay, fx must be equal to 2 times 0 to a. This is from school, actually, school mathematics. 0 to a fx. I can also write dx everywhere. Well, so if fx is even, so basically if this is even, so then what happens if we calculate 0 to 1 fx dx? Let me show here. So if I calculate 0 to 1 fx dx, which means 1 by x square and then dx, this gives what? So if I again write that -1 by x and then lower limit upper limit 0 to 1, first one gives -1 by 1 and then minus -1 by 0. Okay, so the first term is definitely -1, but the second term -1 by 0 will give you -infinity, because this is negative and 1 by 0 is infinity. you can say. So this is an informal way of writing this kind of mathematics. To the end of this video, we will actually see a formal way of writing all this kind of mathematics. Okay, but here just to calculate, it will be minus infinity, and then this becomes minus 1 minus minus, so plus infinity, but minus 1 plus infinity will give you infinity, right? So then 2 times 0 to 1 by x square dx will give what? 2 times, this was calculated to be infinity, 2 times infinity, or better to say plus infinity, then it is again plus infinity. Okay, so 2 times that is infinity, but since 1 by x square is even, this is nothing but minus 1 to 1 f, or I can just write 1 by x square. Okay, so then the integration should give infinity, but we are saying minus 2, so this is another problem, right? Well, so then there must be something going wrong somewhere, right? Where is the problem? To actually talk about the problem, we must introduce the term called, let me use another color, called integrability. 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 And where is exactly the problem? Where is exactly the problem? So basically, which equality does not hold? The equality does not hold is this. Okay, this we cannot write. Yes, we know from our knowledge, from our previous knowledge, that integration of 1 by x square is minus 1 by x. That is for sure. But this minus 1 to 1 and then putting those lower limit or upper limit and straightforward calculation is not valid. That is valid only when the function given, for example, here it is fx equal to 1 by x square. When the function given is integrable, you can do that. Okay, so this is actually invalid, and this is valid only when the function given is integrable, which means what? The function 1 by x square. Okay, but 1 by x square is not integrable. Fx equal to 1 by x square is not integrable. Is not integrable. Okay, so therefore that equation is not always valid, and therefore the problem is actually coming, and we are getting a confusing value or negative value for minus 2, even the integration is for positive function. Well, so what is integrability? We will not go into that in this video, but definitely we understand why that formula and where exactly the formula breaks, and but how to calculate the value, if I ask. So then what is the final answer for minus 1 to 1 fx or 1 by x square here dx? What is the value of this? Well, if this is an even function, I can actually show the graph here. So Desmos graph calculator is excellent in calculating plotting graphs. So I just gave 1 by x square function and it plotted this. We can see everywhere this is positive, and around 0, around the point 0, the values are blowing up, which is absolutely fine because the function is 1 by x square. And this is always symmetric about this because the function was even, and therefore the area under the curve, which means on the negative side of x-axis, like this place and then this place, okay, if you add them up, then only you get the value of the integration minus 1 to 1. And that is that area here. If visually it is also very clear that the total area is twice the area on the right. So basically, if you calculate 0 to 1 and multiply it by 2, then you will get the actual value. Fine. So minus 1 to 1 by x square dx is actually 2 times 0 to 1 by x square dx. Okay, fine. But how to calculate 0 to 1 by x square dx formally? 0 to 1 by x square dx formally. Okay. Well, here 0 is actually a singularity point because we see around 0, 1 by x square is blowing up. It has no finite value. Okay. So what's the actual value and how to calculate this? This comes under improper integral. This is actually given in terms of limit. So what kind of limit? I will first explain here. So basically we are actually finding the integral of 1 by x square on let's say 0 to 1, but around 0 it has no finite value, right? Better you remove a very small part around the 0 point, call this point epsilon. Okay, so then from epsilon to 1 you first integrate, which means from epsilon to 1 you first integrate, which means this is this area, and then take limit epsilon going to 0 plus. Why 0 plus? So basically limit epsilon going to 0 plus, because from the right side we are approaching 0, and then integration you do it on epsilon to 1 by x square dx. Okay, what is this then? This limit again epsilon going to 0 plus 1 by x square, which is of course minus 1 by x, and then epsilon to 1. And over epsilon to 1, as long as we have excluded 0, there is no problem with the function, and it is perfectly integrable. There is no problem. So then, because the point of singularity is now removed, so then from here limit epsilon going to 0 plus, this gives what? This must give a function of epsilon. We'll see how. So minus 1 by 1 minus 1 by epsilon. Okay, so then this gives 1. So basically this is a constant. I can take outside the limit, which is minus 1, and then minus 1 by epsilon. So this must be plus limit epsilon going to 0 plus 1 by epsilon. Okay, fine. So this is minus 1 plus, now the value of the limit. Okay, now we are going back to limit epsilon going to 0 plus 1 by epsilon, or simply limit x going to 0 plus 1 by x. That value is plus infinity. So essentially you are getting the same result, but this is the formal way of doing the integration. Minus 1 plus infinity will give you infinity, and therefore this thing, the value of the actual integral is 2 times this, which is equal to 2 times infinity, and therefore this will give infinity. So actual value of the integral is plus infinity. So we understand that this step is actually not true for functions which have singularities like 1 by x square, okay, in this problem. And a straightforward way of calculation will not stop you, because everywhere it seems to be correct, but finally it is not correct. This cannot be minus 2, right? So in this video we have understood why this integration we have to use, the formula of integration we have to use very cautiously, and that's all in this video. If you found this content very interesting, then do press the like button and consider subscribing our channel to motivate us. I sincerely thank you for watching.